Hi! This instructional video is a continuation on naming, measuring, and drawing angles. If you were to have two rays connected at an endpoint, such as right here, which is called the vertex, and if those rays were exact opposite direction, which forms a straight line, of course, this is now called a straight angle. We talked about that in the last segment. This is a straight angle. Now, if I were to introduce another ray, I just took a rough guess, but suppose from here, the base of this ray to the next one, suppose that's a 40 degree. Now, a straight line, we talked about this in the last segment, where the entire distance from the base to the other end, it forms a 180 degrees. From here to there is 180. And so if you were to introduce this ray at 40 degree angle, what would the remaining degree be? Well, since the entire straight angle is at 180, all you have to do is go 180 degrees minus what we just introduced at 40 degrees. What remains is 140. So this remaining angle is 140, and the relationship between 140 and this 40, they're known to be supplementary angle to each other. Supplementary. 140 degrees is supplementary to the 40 degree that forms a 180 degree straight angle. Or 40 degrees is supplementary to 140. Either way, they're supplementary angle to each other. So, one more example. If I were to say, here's another straight angle, or simply a line, and if I were to introduce another one, suppose like that. And let's just say, assume that this is like 112 degrees. From here to there is 112 degrees. I'm just taking a wild guess. Then what will be the supplementary angle? Again, it's 180 minus 112 this time. So what remains is, let's see, 8, borrow the 7, so 7 minus 1 is 6. So the remaining angle will be 68 degrees, and that will be supplementary to the 112, which forms a straight angle, or the 180 degrees. So supplementary angles add up to be a total of 180 degrees. What about, instead of a straight angle, here's one ray, this is a 9-degree angle now. But on this 9-degree angle, let me introduce, suppose like right there, and let's say that this is 70 degrees. So from here to there, the new ray is at 70 degrees. Then what will be the remaining degrees that goes up to the 90? Well, that's simply 90 minus a 70. And what remains going to be 20 degrees. So from here to there is 20 degrees. And in this case, the 20 degrees is known to be complementary. Complementary angle to the 70 degrees. Or the 70 degrees is complementary to 20 degrees. All in all, complementary angles add up to become a right angle, 90 degrees. So the supplementary was 180 and complementary is 90 degrees. So if I were to introduce another right angle and say, well, there's the international symbol for 90 degree. And then if I told you that, hey, here's another ray that forms an angle, and from here to there, let's say it's 20 degrees. Then what will be its complementary angle? Yeah, so that'll be simply 9 degrees minus the 20. That'll be 70 degrees. Oh, it's kind of, it's the reverse of this one. That was not very original. But once again, you got the idea. The complementary angles, two angles that add up to be 9 degrees. Nope, we're not done yet. Yeah, talking about naming angles. Once again, one additional thing we need to remember is when you have a line, and if you draw a line that intersects it, anytime you do that, anytime you draw a line that intersects the other, what will happen in this case is you will end up with a thing called vertical angle. For example, angle A. is a vertical angle to angle B. And angle A, which is vertical to angle B, their angles will be congruent. So for example, if I took my protractor and measured it, I would say that this is approximately 10, 20, 30, 40, 50, 60, say around 65. So this is about 65 degrees. Well, guess what the B will be then? Since they're congruent, this will also be a 65 degrees. And later on, we'll be talking about a thing called postulate. So they become vertical angles. So angle A and angle B form a vertical angle. Since we're on it, as you can see, when you draw a line that intersects another given line, it will again form a supplementary angle of this straight angle right there. You see that straight line? That's 180 degrees total, isn't it? So that means if this angle A is 65 degrees, then what is this remaining other angle that forms 180 degrees? Well, that'll be 180 minus 65. So that'll be 115. That'll be 115 degrees. And that becomes a supplementary angle to the 65 degrees. And again, this 115 degrees is a vertical angle to its opposite side, sometimes known as the opposite angle. So then this also becomes 115 degrees. Kind of cool, huh? Vertical angle. Now, if you had, we already talked about this. For example, if I were to introduce a pair of lines, let's draw like this one, and then introduce a transversal. Remember that word? A line that intersects a set of lines, two lines. So that becomes a transversal to this pair of lines. Well, here, angle A is a corresponding angle to angle B. So angle A is a corresponding angle. Corresponding angle to angle B. Means they're in the same location. I mean, same idea, corresponding spots, just on a different location. It's kind of like a Corsican brother, if you know about that story, where one brother, if he feels pain on one side of the rib, his twin brother will feel the same exact pain on that same spot. So that corresponding angle is also true if you were to have a set of parallel lines intersected by a transversal. And as we know, this is parallel line because of that arrowhead indicated. And in this case, this angle A and this angle B, they are corresponding angles as well. But also at the same time, because these two lines are parallel, it forms a corresponding angle that is going to be congruent. So in this case, angle A is not only a corresponding angle to angle B, but they're also congruent as well, because these two lines are parallel to each other. So if we were to say this is 100 degrees, well, guess what angle B will be? Yeah, 100 degrees. And we could apply the same logic about vertical angle onto this wonderful thing. If angle A is 100 degrees, its vertical angle is also 100 degrees. And its corresponding angle on this side is 100 degrees as well. Kind of crazy, huh? So vertical angle, corresponding angle, where if two lines are parallel, intersected by a transversal, the corresponding angles are congruent. Not true if they're not parallel. Think about that. Okay then. Now suppose we're going to draw an angle, or we are given an angle. Here, let's just make one. Here it is, here's one, a random angle. Here's a ray. And the second one, something less than a 90 degree, let's say over here. There it is. I have no idea what this angle is. But whatever it is, your teacher is asking you to draw a bisector. A bisector. A bisector. B-I-S-E-C-T-O-R, I think. Or is it E-R? Whatever. Bisector. And the prefix bi, in this case, is indicating not only has to be in the middle, but has to be exactly in between, the same distance between the two rays. Bisector. To separate it into two equal parts. That forms two equal angles, that is. So how do you determine that? You can't just eyeball it and go, like somewhere here. No. And suppose I do have my protractor, but it might fall between the whole numbers, like 40. This is like 40. So it might be 38, 37.5. Oh, that would be nasty. To find a bisector, once again, you're going to use a compass. And you're going to randomly choose an angle of your choice. Suppose like over here. And you're going to match up to the pivot point, the vertex of a compass, then draw an arc to intersect both rays. Right there. Right there. And then what you want to do is come over and use those points where it intersected the rays and use that as a pivot point, and meaning that's going to become the vertex now, or the pivot of this arc. And you want to draw another arc right here, and make sure you go all the way around. It's kind of hard to see here. There we go. There it is. And then you want to come over to the other side, to that pivot point, and then draw another arc intersecting right there. And what has happened is then you have made two separate arcs that are intersecting at 2 points. One there and one there. So what you do is you take a ruler, straight edge, and starting from the vertex of that two rays, if you draw a line and line it up through those 2 points of intersection of the two arcs, what you end up is an exact halfway between this ray, this side, and this side of this angle. And therefore, this is now the bisector. Cool, huh? And the angle here is the same as angle there. And since we are now bisecting an angle, we can use the same method using the compass and bisect a segment, a line segment, or to find the midpoint. Let me demonstrate. How do you find the middle? So in this case, what you want to do is use a compass and somewhere randomly set your compass so that it draws an arc on 2 points. I mean, all the way across, using that pivot point, the end point as a pivot point for your compass. And so in my case, I'm going to draw an arc like so. Ta-da! Well, that was a little awkward. Okay, but there it is. Now, keeping the same angle, don't touch it. I mean, don't change it. Take that the pivot point, end point of that segment, and come over to your side and do the same thing. Just like that. And what just happened is when you have two arcs intersecting, creating a two intersections, you have just created a line that is going to be exactly perpendicular to the line segment, initial line segment. And not only that, it's going to be right in the middle between the two endpoints. Using compass to find the midpoint and draw our perpendicular line, and using a compass to bisect a given angle. Get some.